Bismillahirrahmanirrahim. We are studying automotive technology, and these are my credentials. There is a slight change in the email address. Now, this is my valid email address. Previously, there was another email address, which is now not anymore. So you can contact me on this email address. So these are my credentials. Now, today's topic is the last topic, the chapter 9 of our automotive technology course, that is hybrid vehicles. The basic slide of our course, which we have studied, basically the powertrain or the power flow of a rear wheel drive conventional vehicle. Engine power develop, we have covered that thing in our internal combustion engine subject, and we have covered in very much detail. Then the power which is developed from the engine is transmitted to the flywheel, and from flywheel it goes to the clutch, then to the gearbox, which is also known as the transmission, and then from transmission it goes to the propeller shaft in case of a rear drive vehicle, and then it goes to the differential box, which distributes the power to the right and the left wheel. These were the basic power flow or powertrain in a rear wheel drive conventional vehicle. And the allied subjects which we have studied along with these subjects were the brake, suspension system, steering system, automatic transmission, and now the last topic of this course is the hybrid vehicles. I have divided this chapter into three parts. So this is the first part, in which I will touch upon the basics of the hybrid vehicles and little bit history of the. So background. In the early years of the vehicle development, many different types of propulsion systems were used, including steam engines powered, gasoline engine powered, and electric motors powered. So there were a lot of experiments done in the early 20th century. Many people used steam as the power source, some uses as the gasoline, the petrol or diesel, and some uses the electric motor to propel the vehicle system. The terms which will be using in this chapter, the electric vehicles, the EV vehicles, were also called the battery electric vehicles, BEV, or hybrid electric vehicles, HEV, or zero emission vehicles, ZEV, and fuel cells vehicles, FCV, fuel cells hybrid vehicles, FCHV. Then we have proton exchange membrane, PEM, or polymer electrolyte fuel cell, PEFC. And the last one is the plug-in hybrid electric vehicle, that is PHEV. HEV and PHEV, these are very common terminologies used nowadays. Now, a hybrid vehicle is the one that uses two different methods to propel the vehicle. So a hybrid vehicle basically is the vehicle which uses two different methods to propel the vehicle. A hybrid electric vehicle, abbreviated HEV, uses both an internal combustion engine and an electric motor to propel the vehicle. So it is a combination of your internal combustion engine and electric motor which propels the vehicle. Most hybrid vehicles uses a high voltage battery pack and a combination electric motor and a generator to help or assist a gasoline engine. General trend which is in the hybrid vehicles are the most hybrid vehicles uses a high voltage battery pack and a combination electric motor and a generator to help or assist a gasoline engine. The internal combustion engine, the IC engine, used in a hybrid vehicle can be either a gasoline or diesel. It depends. Although only gasoline-powered engines are currently used in a hybrid vehicle. We can use both type of these gasoline engine or diesel engine, but at the moment, the current fashion in the automotive industry is that we are using only the gasoline-powered engine along with that electrical battery packs. Electrical motor is used to help propel the vehicle, and in some designs is capable of propelling the vehicle alone without having to start the internal combustion engine. So an electric motor is used to help propel the vehicle, and in some design is capable of propelling the vehicle alone without having to start the internal combustion engine. Now, just to give you a brief concept of a hybrid electric vehicle and plug-in hybrid electric vehicle or battery electric vehicle. So let's see this figure. We have engine here. It may be a petrol or diesel engine, and we have the fuel tanks, petrol or diesel, depending upon which type of engine we are using. The fuel is going to the engine. Engine is giving its power to the electric motor, and then electric motor is or power is going direct to the wheels, or in some cases it is giving power to the electric motor and then electric motor is propelling. We will study in this in detail what I am talking about, the series or the parallel combination. And we have a battery bank here, and battery bank gives the power to the electric motor. That electric motor drives the wheel here. So this is the hybrid electric vehicle, simple concept. Now, in plug-in hybrid electric vehicle, we have this battery bank here and the fuel tank here. The fuel which is used for the petrol or diesel engine to propel, to give propulsion, and the battery, from battery it is going to the electric motor, and electric motor is driving the wheels, or the power engine coming from the power going to the wheels. And we have a arrangement to charge the batteries on a specific stations. That is the plug-in hybrid electric vehicle. In simple battery electric vehicle, we only have a battery bank here, and that is battery bank. The power is given to the electric motor. That electric motor propels the wheel. So there is no engine here. So 100% electricity from the grid we are using here. So this was the general concept of the hybrid electric vehicle, plug-in hybrid electric vehicle, and battery electric vehicles. So let's study in some details. Electric vehicles, early electric vehicles. These early electric vehicles use lead acid batteries, an electric traction motor, and a mechanical controller. So in early electric vehicles, we were using lead acid batteries, but now these lead acid batteries are replaced with lithium ion batteries or lithium batteries, and some modern trends are there also. Then we have an electric traction motor which used to propel the wheels, and a mechanical controller which is used to control the electric circuits here. A traction motor is an electric motor used to rotate the drive wheels and propel vehicle. The vehicle moves as a result of traction between the wheels and the road surface to transmit the torque needed to move the vehicle. A traction motor is an electric motor. So basically it's an electric motor used to rotate the drive wheels. Basically it's giving a movement to your drive wheels and propel the vehicle. The vehicle moves as a result of the traction between the wheels and the road surface to transmit the torque needed to move the vehicle. The controller, the mechanical controller, was operated by the driver and allowed different voltages to be applied to the electric motor. So this mechanical controller is operated by the driver, and it's allowed different voltages to be applied to this electric motor, traction motor, depending on the needs of the driver. For example, a two 6-volt batteries connected in a series results in a 12-volt. And as we know, in series, the current is constant, but the voltage increases. So when we are placing two batteries in a series, their voltage combines. So two 6-volt batteries means 6 plus 6, 12 volts batteries, but the current, the same current as of one of the battery. Now, if we are using two 6-volt batteries with 500 amperes, the current are amperes hours, batteries were connected in parallel. In parallel, the voltage remains the constant. Then the voltage would be the 6 volts, but 1000 ampere, because one battery is having 500 ampere hour. So two batteries, then it will be 1000 ampere hours. The old electric vehicle mechanical controller was able to switch all 6 batteries in various combination of series and parallel configuration to achieve lower for the lower voltage for lower speed and higher voltage for higher speed. So this mechanical controller was controlling the voltages in this electric bank. The old electric vehicle mechanical controller was able to switch all 6 batteries in various combination of series and parallel configuration. So basically the mechanical controller was variably controlling the combination of 6 batteries in series and parallel configuration to achieve lower voltage for slow speed and higher voltage for higher speed. Now let's see this example. View of a component of a General Motors electric vehicle EV1. Many of the features of this vehicle, such as regenerative braking, currently used on hybrid vehicles, were first put into production this vehicle. So this regenerative braking is another subject. We will touch upon this. Let's see what are this. So basically we have this engine regenerative braking system here. This is your engine. This is inductive coupled charge port, electrically heated windscreen, centrally located instrument. This is your lead acid storage pack, electric rear drum brake, hydraulic front disc brake, low resistance tire. We have this lead acid batteries and this convenience charger, keypad, hidden antenna, all composite. So this is the previous design of a General Motors electric EV1 vehicle. Now, driving a hybrid vehicle, some unique characteristics that the driver may or may not notice includes. These are the following unique characteristics. After the internal combustion engine has achieved normal operating temperature and other conditions are met, the engine will stop when the vehicle slows down and stops. So after the internal combustion engine has achieved its normal operating temperature, NOT, and the other conditions are met, the engine will stop when the vehicle slows down and stops. The brake pedal may feel different, especially at slow speed of about 5 miles per hour and 15 miles per hour when slowing to a stop. At about these speeds, that the brake system switches from regenerative braking to actually applying brake force to the mechanical brakes. So at slow speeds, your regenerative braking does not work. It's only work as a mechanical brakes. So when the speed is more and you apply a brake, then we have a regenerative braking system. The power steering works even when the engine stops, while all hybrid electric vehicle uses an electric power steering system. So the power steering system, which is basically previously the hydraulic assist was there, in which we have studied in our steering chapter, that power steering works even when the engine stops. So because all hybrid electric vehicle use an electric power steering system. Some hybrid electric vehicles are able to propel the vehicle using the electric motor alone, resulting in quiet operation. In some of the hybrid electric vehicles, which are on propelled by using the electric motor alone, without the help of the engine, result in a quiet operation. If a hybrid electric vehicle is being driven aggressively and at a high rate of acceleration, there is often a feeling that this vehicle is not going to slow down when the accelerator pedal is first released due to the inertia of the rotor of electric motor, and system switches the electric motor from powering the vehicle to generating regenerative braking. So if a hybrid electric vehicle is being driven aggressively and at a high rate of acceleration, there is often a feeling that the vehicle is not going to slow down when the accelerator pedal is first released due to the inertia of the rotor of the electric motor, and the system switches the electric motor from powering the vehicles to generating regenerative braking. Now, the classification of a hybrid electric vehicle, how we can classify a hybrid electric vehicle. We can classify as per the circuit or system which we are using. Four types of classifications are there: series hybrid, parallel hybrid. Series parallel hybrid means combination of series and parallel system, and then belt alternator starter system. So these are the four classification on the basis of the system which we are using. We can classify the hybrid electric vehicle. That is series hybrid, parallel hybrid, series parallel hybrid, belt alternator starter system. So we finish our first part of our lecture. In the next part, we will study these in detail.